This is the Mechanics booklet, question 5. The diagram shows a parasender being towed at constant velocity. This is a very important point. It is telling you that this is an equilibrium situation, so the sum of the forces acting on the parasender will be zero. Next, you are shown these forces in a free body diagram. If you look at the diagram, you can now see the weight of the parasender, the drag that is being experienced, and the tension in the rope. You are given both the values of each of these forces and the angles at which they act, apart from the weight which you are asked to find. The key to this problem is to remember that the sum of the forces is zero, and then to select the vertical direction and analyse all the forces acting in that direction. So we need vertical components of drag and tension, as well as considering the weight. Some of you will be able to look at these forces in the diagram and straight away state their components in the vertical direction. Sometimes we say it is cos of the angle you swing through, or sine of the other angle, if you are going from a resultant to a component. However, this comes with practice, and if you're not confident at that yet, then you must draw a clear triangle. So in this green triangle, we can see that cos of 49 is equal to the adjacent over the hypotenuse, which gives us the vertical component of the drag as d cos 49. You could have worked with the alternative angle up here, the 41, and you'd end up with an expression using sine. Both are equally valid. Do the same thing with the triangle for tension. So cos of 63 is equal to the vertical component of the tension divided by the tension itself on the hypotenuse. This gives the vertical component of the tension as t cos 63, which is the same as t sine 27. You need to work out the technique that works best for you here, and practice is the key. We now have an expression for the vertical component of the drag, the vertical component of the tension, and we want to find the weight. We need to consider how these three forces are related to each other. The key principle is that since it's constant velocity, this is an equilibrium situation, so the sum of the forces in any direction will be zero. You can think of that as the upward force equaling the sum of the two downward forces. Just be careful with directions when making this statement. This line is very important to getting the question right. After this, it becomes a maths problem, just substituting in the values you've previously calculated. Watch out though, the answer line has got the symbol N for newtons, so you need to convert kilonewtons to newtons in your substitutions. This leads to a final answer of 710 newtons.